anyways, like I was saying, Monday was Dalton's law of partial pressures. The only one that was a little bit tricky was number 3, because you had to change it from one of them. I think you need to change it from millimeters of mercury to atmospheres. I had one person that answered everything in millimeters of mercury, and I had to go back and like double check and make sure it was right, but it was right. That was an online one. But normally, if I make this stuff, like, I prefer atmospheres. It's just easier to do the rest of the math. But where is the right button I'm looking for? There it is. So then, and then once they're in the right unit with Dalton's law of partial pressures, you're literally adding or subtracting. Like, that was it. Okay. Now, yesterday with Charles' law, I'm going to put it up here. For those of you that weren't there, I uploaded the YouTube link into Canvas if you need to go into it. But yesterday, Charles' law was the relationship between the initial, the one is for initial, the initial volume and temperature, and then the ending volume and temperature. And then I made sure that people knew how to do the butterfly thing. The two that are diagonal with numbers, you multiply, and then the thing that's left alone by itself is going to be the division number, whether that be on the top or the bottom. Today, we're taking a look at Boyle's law. And Boyle's law deals with pressure and deals with volume. Now, we learned the 4 units of pressure when we did Dalton's law of partial pressures. There's 4 possible ones, even though you really only ever see 3. What are the 4 different types of pressures? What? But there's 4 different pressures. What are the different pressures? This was from Monday. I don't know where I put my clicker for this. I just mentioned 2 of them. Think back to Monday. There's 4 different things that at standard temperature and pressure are equal to each other, but they have different numbers. What are the 4 different pressures? In not pounds per square inch. That's English. In metric. What were we converting in between on Monday? I don't remember. Okay, we've got the 4 different pressures. The one that I like to use are atmospheres. We abbreviate it ATM, all lowercase. The torr is the one that I don't use very often at all. That's TORR. And it's actually the same numerical value as one that we do use a lot, which is millimeters of mercury, which is HG. And then there's one more. Atmospheres, torr, millimeters of mercury, and what's the pressure thing? Atmospheres is the one that I like to use the most often if I get a choice. That's ATM. Torr is the one that I don't use very often at all. That's TORR. But it's also the same value as a millimeter of mercury, MM, and then the H is capitalized, but the G is not. That's the one that we use with barometric pressure a lot. But there's one more. One more pressure unit. It's kilopascals, kPAs. The volume is easy. The volume units are easy. It's normally one of 2 things. What for volume? There's only one of 2 things for volume in science. What are the 2 units for volume of a gas? They're related to each other. Volume. There's 2 common ones that you're going to see for gas. And then that's pressure. Liters and milliliters. Okay, they're the 2 most common ones. Now, when we get into the ideal gas law, we're going to make sure that they're in liters. But for the baby laws, it doesn't matter if you're in milliliters or liters. They just need to match. One cannot be in liters and the other be in milliliters. They have to be the same. Normally, it really should be in liters, but for these 3 small laws, it's okay if it's in milliliters, as long as they're both in milliliters. Atmospheres, torr, millimeters of mercury, and kilopascals. So Boyle's law, this is normally the one when, like all the other schools that I've taught chemistry at, this is the one that I've always started with first, but it's not a big deal. Boyle's law says that the mass does not change. Now I'm gonna put the ideal gas law up here real quick. We're not gonna do the ideal gas law till next week, so please don't let this thing scare you. Eventually we're gonna use this guy. We're probably Wednesday in a week is when we're gonna be doing the ideal gas law. The amount of gas is represented by an M. That's the number of moles. This is just a coefficient from a balanced equation. You're not going to use that yet because, like I said yesterday, if something is constant, it's not part of the problem. It's not. You can ignore it. And it says that the temperature does not change. So that means that the temperature is not going to be part of the problem, which means we don't have to deal with the rate constant. So the only thing that we're dealing with Boyle's law is pressure and volume, because that's the other part of what is called the ideal gas law, which I always thought was absolutely stupid because there is no such thing as an ideal gas. They do not exist, but we have an ideal gas law. I've never understood that ever since I was in high school. With Boyle's law, they are inverses. That means if one goes up, the other must go down. So if the pressure goes up, the volume's going to have to go down and vice versa. That's what this law says. So temperature does not change. It is constant. It's not going to be here. Volume's there. Somehow I got to bring pressure back into this equation too. I'm going to put the combined gas law up here, which is what we're going to be doing Monday. That's what I was actually just printing out. Please don't let all these scare you. We're doing each one individually. So yesterday, Charles' law, the combined gas law just slams them all together. Had no pressure. And that was Charles's law. Today, there is no temperature. And this is Boyle's law. And then tomorrow, there will be no volume. And that is Daly-Sachs law. We're literally just doing it step by step by step. The original notes that Miss Youngman had me teaching all 4 of them at the same time. And then we would add this one the next day. And I was like, no. So we're just putting it on the brakes and we're doing them one at a time, which is how I've always taught it. Oh, okay, I'm sorry. But this really, and I have tried to do this before, but my students were always confused. Really, all I have to teach you is this one. And then if it says if something is constant, you just ignore it. And it'll solve for the formula. But I've learned in the years that I've taught chemistry, it's actually easier for me to do each one separately. You ready? Oh, somewhere, yes. And like I've said before, I do recommend pencil. I need to buy some more. I'm down to 4. That is the formula. That is Boyle's law. Really? What happened? They don't sweep my floors, I've learned here. Ever. Yeah, my floors are disgusting. There we go. All right, so this is the formula for Boyle's law. Like I said, when and I know those of you that are online, you can't see that I wrote the combined gas law on the board. There it is. But when I do cover up temperature from the combined, it does give you Boyle's law. Boyle's law says, remember the ones are the starting or the initial is a word. The 2 are the ending or the final conditions. And I know these are going to be, they're not like super long paragraphs, but they're word problems. And sometimes there'll be a whole sentence in there that has nothing to do with math. When you have in this case, a pressure and a volume in the same sentence, it's not 100% true, but normally those go with each other. So those are either both the 1s or the 2s. Yes, it was. All right. So other times they say it was initially blah blah blah. Those are 1s, or it was changed from this, which is a 1, to something else, which is a 2. You just need to understand the way that it's written, and I can't control the language of the gas law. Really not. I think this is the last note thing, and then we're going to do a problem. Your volume, it is okay right now, but the little ones, not when we do this guy. With the 3 different ones that get slammed together to make this, if there's a volume, it is okay if it's in milliliters. It is okay if it's in liters. But you can't have one volume in liters and a different volume in milliliters. They have to be the same unit. Pressure. Your pressures have to match. Now, if I don't ask you for the answer in a specific unit, and there's two different pressures that are given in the problem, you can choose which one to use, but you have to convert them so that they're both the same. But normally, if I do that to you, I ask you specifically, like answer the question. And like in the case of Mondays, I said specifically I wanted an atmosphere. So this is a review from Monday. Standard STP stands for standard temperature and pressure. Oh, no. Okay, never mind. I read it. Okay, Aiden. Oh, wait, he's not here. Maybe see Aiden.
No.
I want to hear Aiden. Oh, I don't know.
Okay. So, anyways,
Bro, you better be
STP is short for standard temperature and pressure. Yesterday, when we were talking about temperature, we found out that if it's in Celsius, you have to add 273. If you were not here yesterday, the notes are short. They're embedded in Canvas. With chemistry math, with gas law math, you have to be in the Kelvin scale. Now, let me add today's formula up here. Today's doesn't deal with temperature, so you're not doing that today. This is today's. This is the only one you're using. So you don't have to do the conversion to the Kelvin scale. But if you missed yesterday, every time you see Celsius, add 273 to it. It has to be in Kelvin. Celsius doesn't work. Millimeters of mercury, and that's the symbol for mercury, is 760. There's kilopascals, which I've seen it, little k, big P, little a, big K, little p, little a, big K, big P, little kilopascals. And at standard in temperature and pressure, its numerical value is 101.3. That is equal to 760 millimeters of mercury. It's also equal to 760 torr, and it's equal to 1 atmosphere. And the reason why I like using atmospheres is because if you convert, you're dividing or multiplying by 1. That's why that's my personal favorite. But they're all the same thing. Like I said, that's like saying that 1 foot is 12 inches because they're equal to each other. These are equal to each other at standard temperature and pressure, which is sea level. And technically is 20 degrees Celsius. But you don't really need to know that. But that's what it is. Sorry. Atmospheres ATM, torr does not get shortened because it's already short. Millimeters of mercury is mmHg, and then kilopascals is kPa. And that was the pressure. That was the answer to the pressure part of the opener. The top part was the volume answer to the opener. Now you're kilopascals, millimeters of mercury, torr, and atmospheres. There's those 4. There's 4 units for pressure. P is pressure. And like I said, for these, not when we do this one next week, in a week. This one has to be in liters. And depending on your pressure, that's going to control your rate constant. But I'm like getting ahead of myself. That's in a week. If you have 2 different pressures, and let's say you're solving for either a first or a second volume, because that's the missing thing, your pressures do not match, you need to change it. You may have to do one of those 1-step conversions. And if we're doing a 1-step, let me erase these since we aren't using them today. Like, let's say you've got, I don't know, let's say we have 916 millimeters of mercury, and then the other pressure is said to be like 2.4 atmospheres. If I don't tell you a specific, like I want, like, actually, it doesn't really matter. You could switch them into either one, but you either need to change this into atmospheres or change this into millimeters of mercury. And the way that you would switch them, which is like number 3, if you did not do the one from Monday. And I know they can't see me writing on the board. Doesn't matter which way I do it, because the answer would end up coming out the same way no matter what. Okay, so the way, in a one step, where I get these numbers from are right here, where an atmosphere would be 1, the millimeter of mercury would be 760. So either you would switch them both to atmospheres, or you would switch them both to millimeters of mercury, but your volume would still come out right, no matter which way you did it. That's the only thing that I could do to you that's hard, and I'm pretty sure I did not do that to you on this paper. I didn't make a key yet. I was doing my retest for the dinosaur unit, because they bombed that test. Atmospheres, liters. Atmospheres, millimeters of mercury. No, that doesn't look like that was nice to you on this. Besides, it gave you the answers on this one too. Atmospheres. No, they're all the same unit. You don't have to do any of the conversion thing on today's paper at all. As far as notes, there's really not much else that I could do with boils. I'm only going to go through one problem and show you how these work. All right, so the pressure on 5 liters of a gas decreases from, the word from means the 760 millimeters of mercury is my first pressure. 2, the thing it's going to is going to be the second pressure, which is 675 millimeters of mercury. The 5 liters goes with the 760. So if this is my P1, then this is my V1, and then I am solving for V2. That is the hardest part about gas laws, because if you're not getting the right answer that I give you in parentheses, that parenthesis number is not part of your math, that's your answer, then you flip-flop something. So if it's an initial, it's a 1. If it's a final, it's a 2. If it's going from something, that is a 1. If it's going to something, that is a 2. And more often than not, if they're in the same sentence, they go together. Now, just so happen, all of this is in one sentence. You just have to take a second, think, and go, who goes with who? Because I'm guaranteeing you, if you do not get the right answer, you have reversed something. And I had a lot of people in my 8th period that were coming across that. It's just a matter of plugging it into this formula, making sure that you just put them in the right spot. Now, this is how you would rearrange first. Some of my students like to, especially when I teach physics, they like to rearrange first and then plug in. You can do it the other way around. It would be 5 times 760 equals 675 times V2. Okay, and then to get V2 by itself, you would divide both sides by P2, which is how I got here. I did. But I know that some of you, your algebraic reasoning skills need a little bit of a refresher. I mean, every math science class I've ever taught, I have to do this. So if you need help rearranging, please do not be scared to ask me. Even when I teach seniors physics, we spend weeks rearranging formulas. In fact, we always rearrange formulas in that class, which is why it's so simple. Okay, so you can plug in first, which some of you are going to do it that way. So it would be 5 liters. Do not leave off units. Do not give me an answer without a unit. Times 760 equals to 675. We're out of room. No, not. So if this makes more sense to do it this way, do it this way. I don't care. Rearranging it first and then plugging in makes more sense. Do it that way. So you don't want this over here, okay? And since it's originally multiplied, when you take it to the other side of the equal sign, it becomes divided by. Some of you have to see the algebra written down. So that's gone. Yeah, that's gone too. So that's how I got from the original thing to this. And then to put it in the calculator, 'cause this is the only example I'm going to give you. You would do 760. Where's that bouncing? 760 times 5 divided by 675. And I'm going to use 3 sig figs. Gives me 5.63 liters as my new volume. For those of you that like, you can do math in your head a little bit, like you can see, like you see the chalkboard or the dry erase board and you can see the stuff moving. Some of you can do what I'm talking about. Some of you are like, what the hell is this lady talking about? You're going to multiply the ones that you have both of times each other, and you're going to divide by the one that you only have one of. That's how Boyle's laws work. So like with Charles and with Gay-Lussac's, you would multiply the ones that had the diagonals, and then you would divide by the one that was left alone. And for those of you who were not here yesterday, if you need me to show you how to work a proportion properly, I can, because we're done. We have almost 25 minutes. I do not have, let me freeze this. I do, huh? Okay, hold on. Let me stop this first. Otherwise, it's just going to keep recording and recording.